Now let's talk about plotting data. We have one more package here that we'll use. It's called Matplotlib. And this is the whole name of the package. So we're going to import matplotlib.pyplot, and then we're going to give it this alias plt for plot. And then we'll use it to plot different components of our data set, our original DF data set with year and precipitation. So year is just an integer. We can mess around with dates. There are functions or types of data in Pandas that are deal with dates more directly and dates and times. We'll get to that later, I think. For now, let's just learn some basic things. So the way to plot something in Python is to use a bunch of functions, and each one of these changes some attribute of the plot. So the main one is just plot. So plt is our matplot package, and then .plot, that's the function to make a plot, and it gives us a basic line plot. So we just need to give it an x and a y. So the first argument is x, and so we're going to call the year column in our data frame with the brackets, and then the y is going to be our precipitation depth in inches. So this will create a basic scatter plot. And let me, or I think it's actually a basic line plot. So if I comment all these out, let's just see what this gives us. Okay, so we get a basic line plot. That's kind of what's built in. The default color is blue, the line plot, but we don't have any name labels for our axes or anything like that. So we're going to just start adding stuff to it. So the scatter gives us points. So a scatter plot is just like a point plot. Okay, so now I added points. Again, the default color is blue, and I use this function scatter to do that. And then now we're going to add an X and a Y label and a title. So the title, X label, and Y label. So that's our little basic plot. And now we can copy and paste this and start to change things. I'll just note that this last thing shows the actual plot. Okay, so we can change the color. And like I said, the default color is blue if you don't add an argument for the color. But here we can go in and say, for the plot, I want the color argument to be green. And for the scatter, I'm going to change it to a little bit different color, medium sea green. There are a lot of ways to specify colors in Python. So here's a little thing to learn more about it. And this just gives you the idea of what you can do. So you can say color equals B. That has to be a string, so in quotes, or R. So here's some basics. You can give it these colors right here, or you can give it these. These are just names of all the different colors. I was using these names. And then there's a whole range of other options. You can do hexadecimal, RGB, yada, yada. You can change the transparency. So I'll let you dig more into this if you want. Sometimes for precipitation data, we plot it as vertical bars. And so this is called a stem plot in Python. You can also do a bar plot. Stem plot is just lines. I don't want little points at the end of these, so I said marker format equals blank. So just blank in quotation marks. And then this is the way we specify colors in stem plot. Some plots will have different ways of specifying colors. You just have to Google this particular function in Matplot and figure out how to do that. And I'm just going to add plt.show. For some reason, if you don't add that, it'll print this weird text, and we just don't need that. So there we go. So on your own, I want you to create your own version of a stem plot or a scatter plot. Try to mess around with the line widths and colors. You can use the AI coding Copilot tool to help, or Google, and so make your own plot. All right, now we're going to think about histograms. Histograms are a way, like we talked about in first week, to show the distribution of our data set. And what it does is creates bins for continuous data. And then with those bins, it enumerates how many observations fell in that range. So if I just use hist, this is the histogram function in Matplotlib, and I give it It just needs one value, right? It just needs the precipitation depth. I tell it, give me 10 bins. If I want to have the edge colored a certain color, I can specify that. And then the same title, label, etc. So here's some data. Here are 10 bins. Give me a histogram. But we can tell it to give us the number of bins. We can also tell it to give us the actual bins themselves. And so to do that, we're going to use this function arrange. And this is under NumPy. So you have to make sure NumPy is loaded. So np.arrange. And then what it says is, okay, start from 40, go to 70, and then give me intervals of 5. So min, max, interval. And then what that does is you can see I have then bins that go by 5s. I think up here it was some arbitrary value, right? You can see these bin bars don't fall nicely. So now I have 5 bins. That's just how it worked out. 1, 2, 3, 4, 5. It didn't have any values. It looks like above 70. I don't know. I changed the color to slate blue. This is kind of a nice purple color. And then here, one more thing to note is that what are the Y values here? The Y values are simply frequency or count. So how many values fell within each bin? Well, I can change that to density. And I've talked about density kind of briefly. We're going to spend a lot of time learning about it. For histograms, density essentially represents the probability per unit width. And something about density, the way it works, is that if I were to take this Y value, you can see the Y values are a little bit different here, right? The same shape, but different Y values. If I take this Y value for this bin, and I multiply it by the width to get the area, and sum all of these up, guess what? They sum up to 1. So density tells us that it's basically the kind of area represents the probability of these observations within each bin. So I want you to create your own histogram and alter the bin width to make them narrower and wider than what we have here, the 5 bins, or the 5 bin width. And then comment on how this changes your interpretation of the mean, the mode, and spread of the data among the narrow, medium, and wide bins. So you have 3 plots. This is one of them, and then you're going to make a narrower one for bins and then a wider one for bins. And then in your own words, define probability density, write out the formula for this for a histogram, and you can check back in chapter 1 on that. Okay, one more thing to talk about here, and that's box plots, box and whisker plots. We are going to use a new data set here, and it's going to have basically 2 columns that we're interested in. This is air quality data, average particulate matter 2.5. So the concentration of really tiny 2.5 micron or less particles in the air. These come from car exhaust and factories and affect our lungs and help create ozone, create cardiovascular disease and asthma. So I've got a data series of a year of data approximately for average air quality in Grand Junction at a location, and then another location in urban Denver. So that's what this data table is. So PM particulate matter data 2023. So you'll load this CSV using Pandas. Remember, Pandas has to be loaded, and we're going to call it PM data. And then here is the head of that. So I've got concentration, and it's micrograms per cubic meter. I'm going to create a box plot, and the way to do that is just the box plot function, pretty straightforward. We're going to apply it to our PM data, right? So PM data.boxplot. I have to specify what I want the columns to be. So in this case, I have 2 columns that I want to plot, 2 box plots. And so I specify the names of the 2 columns. And then I can actually set the X labels for that using this function right here. And then plot, title, Y label, and then show. So here is my side-by-side box plots. And you can see here's the interquartile range, the median, and then that 1.5 times the upper and lower IQR for the whiskers, and then my outliers, or just extreme values, we'll just call them. So to wrap this thing up, we've got 3 questions for you. I want you to compare them and contrast the median, interquartile range, and outliers between these 2 data series and talk about why that might be. I want you to create a single box plot based on the annual precipitation data, so that original DF data frame, and then describe the box plots. And then finally, this is kind of like your little challenge. I want you to create overlapping histograms with different colors for the PM data, for the particulate matter data. And I give you a link that goes over that, and you can also use online tools or AI to help you with that. So create overlapping histograms, not stacked, so just the kind of overlapping, and then use that and describe it. So describe the 2 distributions from a histogram standpoint. All right, and that's it.